Welcome to our tutorial class in grade 8 mathematics. Good day, students, and welcome to another episode of Learning Mathematics. By the way, I am Teacher Francisco, who will guide you in answering all the activities in your module. Are you ready? Let's go! But before that, I want you to know that in this video, you will examine the aforementioned questions when you study the following lessons. Lesson 1. The basic concepts of probability. In this lesson, you will define experiment, outcome, sample space, and event. Lesson 2. It talks about probability of an event, experimental probability, and theoretical probability. In this lesson, you will explain and interpret the probability of an event and differentiate between an experimental probability and a theoretical probability. Lesson 3. This is about organizing outcomes of an event and the fundamental counting principle. You will know how to count the number of occurrences of an outcome in an experiment. Lesson 4. Problems involving probability of an event. You will apply the lesson in real-life situation by solving simple problems involving probability of an event. Those are the 4 lessons of probability in our module. As we get closer to our topic, let me ask you some questions. First, have you heard in the TV when Kuya Kim Atienza or Mang Tani reported on weather updates saying the chance of rain tomorrow is 90%? What does it mean? Second, once you are vaccinated, how many percent is the chance that you will be safe from COVID-19? Third, in a family, if the firstborn is a boy and the secondborn is a girl, what is the probability that the third one will be a baby boy? Those questions or problems I mentioned earlier are all related to our topic today, which is probability. What is probability then? How did the study of probability start? The study of probability started in the 17th century when the two French mathematicians Blaise Pascal and Pierre de Fermat were consulted by gamblers regarding how likely they will win in a game of chance. This made Pascal and Fermat conduct documented scientific study on probability and later developed the theory of probability. Today, there are many uses of probability, especially in the field of physical sciences like meteorology and medicine, social sciences, sports and games, politics, and finance and business. What is probability? Probability is a branch of mathematics that deals with uncertainty. By definition, it is a measure or estimation of how likely it is that an event will occur. Events cannot be predicted with total certainty. We can say how likely they are to happen. For example, what is the chance or probability that it will rain today. If you will say 10% only, that is because we have a good weather. Another example. How many percent that you could pass this subject? If you will be serious in your studies, then you will have a big chance to pass the subject. Probably you might say, I have 99% of chance to pass this subject for the reason that I really love numbers. At this point, I will illustrate the basic concepts of probability. We need to understand these important terms of probability, namely experiment, outcome, sample space, sample point, or event. Experiment. The term experiment will be used here as an activity with observable results, which means to say that it could be repeated over and over again and which have well-defined results. What are examples of activities that illustrate experiment? These are tossing or flipping a coin, rolling a die or dice if many, picking a card from a standard deck of cards, or drawing a ball in a lottery. The next term we should learn is outcome. Outcome is the possible result of an experiment. For example, when you are tossing a coin, there are only two possible outcomes. It could be either head or tail. In case of rolling a die, there are 6 possible outcomes. It could be 1 or 2 or 3 or 4 or 5 or 6. But 7 cannot be an outcome since there are only 6 faces in a die. Sample space is another basic term of probability. It is the set of all possible outcomes for a probability experiment or activity. It is usually denoted by the letter S. In tossing a coin, the sample space can be written as sample space is a set of head, tail, since there are only 2 possible outcomes. Whereas in tossing 2 coins simultaneously, there are 4 possible outcomes. It could be both heads for the 2 coins, or head for the first coin and tail for the second coin, or both tails for the 2 coins, or tail for the first coin and head for the second coin. So to write the sample space, it can be written as sample space is a set of head, head, tail, tail, or tail, head. What about when you toss a coin and roll a die simultaneously? How many outcomes are possible? How are you going to write the sample space? Write your answer in your activity 5 on page 9. We need also to learn sample point. Sample point is the individual outcome. It is an event that refers to any subset of sample space. In a die, any number from 1 to 6 is an example of sample point. In the set of standard deck of cards, any card could be an example of sample point. However, king is not a sample point because there are 4 kings, which are 4 different sample points in a deck of cards. At this point, I will guide you now in answering the other activities in your module. Proceed to activity 3 and 4. For activities 1 and 2, you can do them yourself because they are easy tasks. For activity 3 on page 6, you have to complete the table. 3 cells are already completed to serve as your guide. For activity 4 on page 8 to 9, I'll give you 5 examples. The same instructions. Use the basic concepts of probability to identify the following. Choose your answer inside the box. Let's try this. Number 1. Picking a card from standard deck of cards. What is your answer? If your answer is experiment, then you are correct. Number 2. Head, tail. Give me your answer. Yes. Sample space is correct. Number 3. Ace of heart. Anybody who wants to answer? Yes. Event? No. Any answer? Sample point is the correct answer. Let's continue. Number 4. It deals with uncertainty. This is very easy. Correct. The answer is probability. Last example. Getting a 5 in a single roll of die. People at the back, what's your answer? Event is the correct answer. Congratulations, learners, for the job well done. Let's continue to our next lesson. Lesson 2 aims to illustrate probability of an event and differentiate experimental probability from theoretical probability. Probability of an event, or P of event, or simply P of E, is a number from 0 to 1 which tells us how likely the event is to happen. The more likely an event is to occur, the higher its probability. On the other hand, the less likely an event is to occur, the lower its probability. In computing the probability of an event, we will use this formula. Probability of event is equal to the number of favorable outcomes divided by the number of all possible outcomes. This is what we call a probability line. The probability rules are guided by this line. First rule. The probability of any event is a number, either a fraction, a decimal, or a percent from 0 to 1. There's no such probability that will exceed to 1 or less than 0. For example, the weather forecast shows a 70% rain. The probability of rain, which is our event, is equal to 70%. In decimal, that's equivalent to 0.70. In fraction, that is 70 over 100 or 7 over 10. Second, if an event will never happen, then its probability is 0. Example, when a single die is rolled, find the probability of getting an 8. Since the sample space consists of 1, 2, 3, 4, 5, and 6, it is impossible to get an 8. Therefore, probability of 8 is equal to 0 over 6 or 0. The third probability rule is if an event is sure to happen, then the probability is 1. For example, when a single die is rolled, what is the probability of getting a number less than 7? Since all the outcomes from 1 to 6 are less than 7, the probability of number less than 7 is equal to 6 over 6 or 1. The last rule, it says, the sum of the probabilities of all the outcomes in the sample space is 1. For example, in rolling a fair die, each outcome in the sample space has a probability of 1 over 6. Hence, the sum of the probabilities of the outcomes is 1. Let's continue our discussion on how to find the experimental probability and theoretical probability. What is the difference between these two types of probability? Do they have the same formula? The difference between these two in terms of definition is that experimental probability is found by repeating an experiment and recording the outcomes, whereas the theoretical probability is what is expected to happen based on reasoning or calculation. Now, what about in finding the probability of an event experimentally and theoretically? For experimental probability, you have to conduct an experiment and record the number of times the event occurs and the number of times the activity is performed. Divide the two numbers to obtain the experimental probability. Whereas in theoretical probability, the theoretical probability of an event is the number of ways the event occur or the favorable outcomes divided by the number of total outcomes. In terms of formula, for experimental probability, to solve the probability of any event that is computed by dividing the number of times that the event occurs by the total number of trials. Whereas for the theoretical probability, to find the probability of event, it is computed also by dividing the number of favorable outcomes by the total number of possible outcomes. Let's proceed to the example. For experimental probability, a coin is tossed 10 times. A head is recorded 7 times and a tail 3 times. So in this experiment, the total number of trials is 10 and the number of times that the head occurs is 7 times and a tail 3 times. So therefore, the probability of head event is equal to 7 over 10, whereas the probability of tail is equal to 3 over 10. Example for the theoretical probability. A coin is tossed. What is the probability of getting head or getting tail? We all know that in a coin there are two possible outcomes, and there is one favorable outcome for head and one favorable outcome for tail. So therefore, the probability of head is equal to 1/2, and also the probability of tail is 1/2. In your activity on page 15, you will perform the experimental probability. You will toss 3 coins simultaneously in 10 trials. Observe the outcomes and record them on the table. Trial 1 is an example only. You have to perform your own trials. Let's have more examples in finding the theoretical probability of an event so that you will have an idea on how to answer your activity 1 and 2 on page 13 and 14. Problem number 1. If one letter is chosen at random from the word probability, what is the probability that the letter chosen is a consonant? The word probability has 11 letters and there are 7 consonants. So the probability that the letter chosen is a consonant is equal to 7 over 11. Second problem. A box contains 3 red balls, 7 orange balls, 4 yellow balls, and 6 green balls. What is the probability of drawing out a yellow ball? In this kind of problem, we will add all the balls inside the box. 3 plus 7 plus 4 plus 6, that is equal to 20, which is the total possible outcomes. And there are 4 yellow balls. To solve the probability of drawing a yellow ball, that is, probability of yellow ball is equal to 4 over 20. Since it can be reduced to lowest term, it becomes 1 over 5. In decimal, 0.2, and in percent, 20%. It means it has poor chance to draw a yellow ball. Concludes our session for today, but the remaining 2 lessons will be continued next week. I hope you were guided in learning today's lesson. I know it's impossible that you can't do it, because I'm certain that you can. Just assure you'll return the modules with correct answers. Rest assured you'll have a big probability to pass. God bless and keep safe, everyone.